Hey class, welcome back. This is week 6 of remote learning. As some of you may or may not have heard, we may only have 3 more weeks of school left this year, which is kind of crazy to think about. But pending the approval of the Board of Education tonight, Monday night, they may approve that we just have 3 more weeks of remote learning, which means we only have 9 more class periods, all right? But that does give us just enough time to finish up this chapter 8 on solving quadratic equations. All right. So today's lesson is going to be about simplifying radicals. All right. And actually, this week is all going to be about simplifying radicals. All right. So today's day 1 of it. Tomorrow will be day 2. And then on Friday, I have a little quiz review. And that'll be for solving radicals, which you'll need to use those skills for the next 2 weeks. All right. So that being said, we're going to start with a couple little 4 warm-up problems here, right? I want you guys to go ahead and pause this video and just simplify these 4 radicals. All right, so let's see. Hopefully you guys got the same answers as I did, right? So number 1 here, the square root of 36, right, is just 6. The square root of 81 is just 9. The square root of 144 is just 12. All right, and number 4, the square root of negative 100, right, is just going to be negative 10. Right, the negative on the outside just kind of stays on the outside, right? So those numbers there, right, 36, 81, 144, 100, right, those are known as the perfect square numbers, all right? And perfect square numbers are numbers whose square roots are integers, all right? So what does that mean? All right, so if we look at our factors chart here, here's another way you can look at it. All right, we may not need to reference a factors chart, but I just want to kind of give you an idea of where this perfect squared number comes from and why are these called perfect squares, right? So if we looked at our factors chart here, right, which we've pretty much been using this whole time during remote learning. All right, so if we look at like the number 4 example, right, you can see that it is 2 and 2, right? Because 2 and 2 make 4, right? That's a perfect squared number because it's both 2's, right? Just like 1 is 1 and 1, 2 is 2 and 2, right? 9 has 3 and 3, right? 16, 4 and 4, and so on and so forth, okay? So that's kind of where this idea of perfect squares come from, right? It's perfect root integers. All right, so here is the first 12 perfect squares, right? And those perfect square numbers are the ones that are in the boxes, right? Or the squares, all right? So these are the important numbers that we need to find when we're simplifying radicals here. All right, so these numbers that are boxed up, again, are the important numbers that we need to find. We need to break down numbers into products of perfect squares and non-perfect squares. All right, and here's kind of the 2 key ideas with simplifying radicals. All right, so if you're not able to print out these notes here, all right, this is definitely something that you want to write down in your notes. All right, you want to write down, right, to simplify radicals, you must use this multiplication property of square roots. All right, and here is this multiplication property of square roots. All right, it says that the square root of a times b is equal to the square root of a times the square root of b. All right, so you can basically break up any number inside the radical into 2 separate numbers, all right, that multiply back to the original problem. All right, so and then a radical expression is in the simplest form if and only if there are no more perfect square factors inside the radical. All right, and I'll kind of talk about more what that means when we do these example problems here on page 2. All right, so let's look at some examples here. All right, we have the square root of 18. All right, and the directions are to simplify the following radicals. All right, so I have this number 18. All right, I want to break up 18 into 2 numbers. All right, or 2 factors. All right, but one of those numbers need to be one of these perfect square numbers. All right, so one of the ways you can do this is by looking at the factor chart, right? Find the number 18 and look for those perfect square numbers, right? 1, 4, 9, 16, all right? And if we look at the numbers, right, we can see that 2 times 9 is 18. So there's one of those perfect square numbers, all right? But that's going to take some time and that's going to use that chart, and it's a lot of going back and forth, all right? So the other way you could do this, all right, is by using a calculator, all right? Use a calculator on your phone, use a calculator on the computer, all right, or use a regular calculator. All right, so we can take that number 18, all right, and we want to divide it by one of these perfect squared numbers, all right? So again, here's those perfect squared numbers, all right? So you want those perfect squared numbers handy, or you want them like nearby, or just kind of get them memorized if you can. All right, so we're going to take that number 18 and we're going to divide it by one of these perfect square numbers. All right, well, obviously these numbers on the right here, those are going to be way too big, all right, to go into 18 evenly. All right, so then we look at this side here, right? 25 is way too big. All right, so then I'm looking at these four perfect square numbers right here, right? 16, 9, 4, and 1. Well, 16 is not going to divide evenly into 18. Right? If I try that, get 1.125. All right. But I already know that 18 will divide into it. Right. So I can take 18 divided by 9. 18 divided by 9 gives me 2. All right. So that is what I'm looking for. I'm looking for two whole numbers here. All right. So I'm going to take that square root of 18 and I'm going to break it down into the square root of 9 times the square root of 2. All right, and this is the work I'm going to look for from you guys. All right, I don't want just an answer, because you can use a calculator or a phone or an app to give you the answer. I need to see this step right here. All right, I need you to see you breaking down a number into two different numbers. All right, and here's that perfect square number, right? That square root of 9, that is what I'm looking for. And the square root of 9 is 3. So then my final answer is 3 times rad 2, or just 3 rad 2. All right, because when numbers are next to each other in math, right, that means they're being multiplied. All right, so that's how you would simplify the square root of 18. All right, and now for the square root of 50. All right, again, I'm going to break up this number 50 into two of its factors, but one of these factors needs to be that perfect squared number. All right, times some other radical number here. All right, so then it's same thing, right? If we don't know what numbers go into 50, all right, we would just simply use this calculator, all right, and start dividing, all right, by these perfect square numbers up here. All right, again, if I had that number 50, all right, so I got to figure out what number is going to go into 50. And I want to find the biggest number that can go into 50. All right, so you can type in 50 into your calculator, and let's see, I know 64 doesn't go in 49. I know 25 maybe will go into it. So you take 50 and you would divide it by 25. And it does go into the ability 2 times, right? 50 times 2. I'm sorry, 25 times 2 is 50. All right, so that means I'm going to break up this rad 50 into the square root of 25 times the square root of 2, right? So this is my perfect square number. Square root of 25 is just 5. So my final answer is 5 rad 2. All right, what if there's a number in front of this radical? All right, again, this really means that it's 3 times the square root of 20. All right, that's all that means. All right, we put them together because in math, you don't need to write that little dot. All right, so I'm going to follow my same rules. All right, I have to break up this radical, right? The square root of 20, I need to break up into some perfect square number times some other radical number. Oh, I don't know that it's 2. All right. And when I'm doing this, if I need to find the biggest perfect squared number first, it's going to make my life easier at the end. All right. So again, I got to take this number 20 and I have to divide some numbers into 20 to see what is that perfect squared number that goes inside of 20. All right. Or to divide evenly inside of 20. All right. Well, let's see here. Where did my little calculator go? Oh, here it is. All right. So I'm going to take that number 20 and I'm going to start dividing by some perfect squared number. All right, so 20 divided by 16, does that work? Nope, that's 1.125. All right, how about 20 divided by 9? Is that going evenly? Nope, that's 2.222. That doesn't work. How about 20 divided by 4? Bing, 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 there it is, all right, because 4 times 5 is 20, so that means 4 is going to be my biggest perfect squared number that divides evenly into 20. All right, so that means the square root of 20, I'm going to break up into the square root of 4 times the square root of 5. All right, and there's 3, right, just kind of goes on the outside for now, right, and it's really 3 times this stuff. All right, and here's my perfect square, right, my square root of 4, again, the square root of 4 is equal to 2. All right, so this perfect square number turns into 2. I bring down this 3 times 2 times rad 5. All right, now I can just clean this up, right? I'm just going to follow my normal multiplication procedures here, right? And I can multiply 3 times 2, which gives me 6. So my final simplified solution is 6 rad 5. All right, again, when you're doing these problems, I do need to see your work, all right? I can't just see your final answer. I need to see those numbers broken down here. All right, so here are kind of the steps again that I just did for these 3 example problems. All right, so step 1 is to always look for the largest or the biggest perfect square number. If you can find that largest perfect square number first, that's going to make simplifying a little bit more easier, okay? Because sometimes some numbers have multiple perfect squares that are divisible by them, but we want to find the biggest one first. All right, so when you start dividing, you want to divide from the biggest and kind of work down. All right, so after you find that largest perfect square factor, all right, you want to use that multiplication property of square roots to separate your perfect square from the rest. Okay, so that's what I'm talking about right here. You separate into rad A times rad B, right? You're going to take a number and you're going to separate it into 2 different numbers. All right, and then after you do that, you want to take the square root of that perfect number and leave any numbers that are not perfect squares inside the radical. All right, and a special note here, right? Any numbers outside of the radical can be multiplied together. All right, that's like what we did in example 7 here, right? This 3 was in the outside, so we did 3 times 2. All right, so let's do some more practice. All right, and again, here's a list of these perfect square numbers. All right, so if you're not able to print out these notes, have these perfect square numbers written out on the top of your page. All right, and I would recommend having it written out on the top of every single page that you do when you're doing these radical problems and you're simplifying. All right, so here we go. So we have the square root of 8, right? And we need to simplify the square root of 8. All right, so here's my calculator. All right, so I'm going to take that number 8, and I'm going to start dividing it by one of these perfect square numbers. Well, 9 doesn't go into 8, so my next smallest one is 4. So 8 divided by 4 is 2. Oh, yeah, duh, I knew that. All right, so here I'm going to separate the square root of 8 into the square root of 4 times the square root of 2. All right, and I'm just boxing this up because that is my perfect square number, and that's what I need. All right, the square root of 4 is 2. So then my simplified answer is 2 rad 2. All right, so here's the square root of 32. All right, so some of you may think, oh, wait, I know 8 times 4 is 32, right? Which is fine, which is true. And if you did that, you would be partially correct. All right, however, right, this is one of those numbers where there's 2 perfect squares that divide evenly into 32. All right, so yes, if you took 32 and you divide it by 4, which you knew, right, 4 and 8, that goes out evenly. All right, however, there is a bigger perfect square number that goes inside of 32 or divides evenly into 32, and that is 16. All right, so for this one, we would want to divide 32 by 16, and we would see that it divides evenly and gives us 2. So for example 9 here, right, we would ideally want to break this up into the square root of 16 times the square root of 2. All right, because that rad 16 is going to be the biggest perfect square that divides evenly into 32. All right, and that square root of 16 is 4. So then my final simplified solution is 4 rad 2. All right, for number 10, we get the square root of 27. All right, again, we're going to break down the square root of 27 into 2 numbers. All right, one number is going to be a perfect square number times the other factor that makes up 27. All right, so if we grab user calculator again, right, we're going to type in 27. And we're going to start dividing by these perfect square numbers, all right? Well, 25, I know can't go into 27, it's too close to it, all right? So maybe I would start with dividing it by 16 to see if that works. Nope, I get 1.6875. All right, so then I take 27, and I'm going to divide it by the next biggest perfect square, which is 9. Oh, yeah, that's right. 9 times 3 is 27. So now I can do the square root of 9 times the square root of 3. All right, and the square root of 9, that's my perfect square, right? That's going to simplify to 3, and then this comes rad 3, and that is my simplified answer, 3 rad 3, or 3 root 3. All right, why don't you guys try number 11, pause the video, and find that biggest perfect squared number that goes inside of 60. All right, let's see how you did here. All right, so now I'm going to break up rad 60, right? What is that biggest perfect squared number that divides into rad 60? All right, well, let's get my trusty calculator out here. All right, so again, we're going to type in 60, and we're going to start dividing by these perfect squared numbers. Well, 64 is too big, so maybe I'll try 49. Oop. So 60 divided by 49. Nope, that doesn't work. How about the next one, 36? 60 divided by 36. Nope, that didn't work. 60 divided by 25. Nope. Oh, maybe I should give up. Oh, wait a second. No. All right, just keep going down the line. All right, 60 divided by 9. 6. Nope. Okay, you got a couple more left, right? So it has to be 60 divided by 4. There it is. Okay, so just keep trying. All right, sometimes it's going to take you all the way down to the end. All right, but again, you always want to start with the biggest one because it's going to make it a little bit easier to simplify at the end. All right, so the square root of 60, right, is going to be broken down into the square root of 4 times the square root of 15. All right, and this square root of 4, that is my perfect square, right? That's why I'm putting this box around, because that is my perfect square. So now that becomes 2 rad 15, and that's going to be my simplified answer. All right, on the last two here, right, these are the ones like in example 7 above, right, where there's a number out in front. All right, all that really means is that it's going to be 2 times the rad 48, or the square root of 48. All right, so all that means is just I got to bring that 2 down for now. All right, so again, I want to break up 48 into 2 numbers. All right, and one of these numbers needs to be a perfect squared number. All right, so again, same thing, right? You use your calculator, and I'm going to take that number 48, and I'm going to start dividing. All right, I'm going to try 36. Nope. I'm going to try 25. Well, I know 25 is not going to work, so I'm going to try 16. And there it is. All right, so 48, you're going to break down into the square root of 16 times the square root of 3. All right, and this is my perfect square here. That square root of 16, that turns into a 4. All right, and it's a 4, not a rad 4. All right, so I'm not going to take the square root again. All right, once you use that perfect square, you're done with that radical. All right, so now I have 2 times 4, which is 8. Rad 3 is my final simplified solution. All right, again, once you guys try number 13, all right, try to work the whole thing out. Pause the video and let me know what you get. All right, let's see how we did here. So we have 6 times, right? We have the square root of some number, the perfect square number of 12 times another square root here. I've already given away the answer there. All right, so now let's see. So we have 12, right? Well, 12, I can't do 16, so 9 doesn't go on the 12, so it's probably going to be 4. All right, so 12 divided by 4, yeah, 12 times 4 is 3. All right, so that means 4 is the largest perfect square factor of 12. And I'm going to break up the square root of 12 into the square root of 4 times the square root of 3. All right, and now this square root of 4, that's my perfect square, right? That's going to be 2. So now I have 6 times 2 times rad 3. Right, and these are just numbers that can be multiplied. All right, so 6 times 2 gives me 12. So my final simplified solution is 12 rad 3. All right, so now it's time for you to practice some homework problems. All right, again, I do not want to see just the answers. All right, I need that first step. I need to see what are you breaking down each of these numbers into. All right.